let's get into how quadratics can be applied to business applications. So the main things we're going to be looking at is finding the break-even points using cost and revenue. So remember, that's when cost and revenue are equal. And we're going to maximize revenue or profit if they're quadratic. We're also going to graph quadratic and supply and demand functions because they're not always linear. In Unit 1, everything was linear, and that's not really how things work. Things have ups and downs and that sort of thing. We'll also find market equilibrium using quadratic supply and demand. So let's start with the break-even points. So when we know that the functions for total cost is C of X and total revenue is R of X, we can find the break-even point for figuring out when the cost equals the revenue. So how much you're spending equals how much you're bringing in. It makes sense. One thing we want to kind of bring up is in a monopoly market, the revenue of a company is restricted by the demand for the product. And that makes sense. In this case, the relationship between the price of the product and the number of units sold is described by the demand function P equals F of X. So the price depends on how many units are sold. And so the total revenue is going to be, the revenue will be the price, the price times the number of products sold. Now just remember that the price depends on how many are sold. So let's suppose that we have a monopoly market. The total cost per week of producing a high-tech product is given by this function. Suppose further that the weekly demand function for this product is given by 500 minus 2x. All right, and we want to find the number of units that will give us that break-even point. Okay, so we have our cost function. Awesome. We need our revenue function. So revenue is made by our price times the number of units. So in this case, our price, so price times the number of units. Well, our price is given as a function of X. It depends on how many units we sell. So our revenue is going to be the demand is 500 minus 2x, so that's giving us our price for it, times how many we sell. So we end up getting, that'd be 500x minus 2x squared. Okay, so that's my revenue. And we want to know when the cost and the revenue are equal. So I want to know when the cost equals the revenue. Well, here's cost is 3,600 plus 100x plus 2x squared. And we want to know when that equals 500x minus 2x squared. Now there's a couple of ways to do this. I'm actually going to talk about both of them. One way is we can do it algebraically. Now we can get everything on one side and solve for x. So I'm going to do that first. So if I get everything on one side, if I add this 2x squared, I'm going to end up with 4x squareds. And then I would have to subtract the 500x, so that would give me negative 400x. And then we'd still have that 3,600 there. And then we'd have 0 on this side. Everything's divisible by 4, so I could technically just divide both sides by 4. X squared minus 100x plus 900 equals 0. How nice. I think this one's going to come out really pretty because 900 would be 90 times 10. So I could have x minus 90 and x minus 10. So I get 2 answers. So let's think about what that means. That means we have 2 times that we have break-even points. Let me show it to you a different way. Okay, so if I go into my calculator, let me put in the cost function. And then in Y2, I'm going to put in my revenue function. And I'm going to have to play with my window a little bit. I kind of know that I need to get pretty high up. So I kind of have an idea of how to set this up. If you were doing this yourself, you would have to kind of play with the window. But I know we can't have products under 0. And by doing this, I know I'm going to need at least 90. So I'm going to go way past that because I want to see a good picture. I'm going to go like 150 there. And then we're not going to have cost of 0. This has got to be in the thousands. I'm just going to go with 50,000. And let's look at the graph. Okay, so here's my cost function. There's the revenue function. So what does it mean when this revenue function, the red line, is above the cost function? Well, that means so when the revenue is higher than the cost, the revenue is bigger than the cost, we're going to have a profit. So remember that these are where they're crossing at 10 and 90. So we are going to have a profit if we sell between 10 and 90 units. And it's weird because if we actually sell more than 90 units, the price is going down, so we actually start losing money. But this question just asks us when is our break-even points, and it's at 10 and 90. So we have to make at least 10, but no more than 90. So we will make a profit if we sell between them. Okay. So again, let's talk about that same group. We have the total cost function and the revenue function. And what if we wanted to find the number of units that would make us the most profit, the maximum profit? Well, actually, okay, find the number of units for the maximum profit. So it doesn't say maximum revenue, because you see that the revenue function actually has its maximum over here, but that's not going to give me my maximum profit. So let's remember how to find profit. So profit is going to be revenue minus our cost. So it's a brand new function. Profit is found by taking the revenue, which was 500x minus 2x squared, and we're going to subtract the cost. And let's see what this new function looks like. So I'm going to do a little simplifying. And that's going to give me negative 3600 minus 100x minus 2x squared. And let's kind of combine like terms and clean this up to make it prettier. That would be negative 4x squared and then plus 400x, and then it'd be a minus 3600. And I want to know where this is going to have a maximum. So think about it. This is a quadratic that's opening down. My maximum is going to happen at the vertex of the profit function. So remember, we're going to have to find the vertex using that little formula. So to find the vertex, I'm going to find the x value with negative b over 2a, which b is 400. So that's negative 400 divided by 2 times negative 4. And that's going to end up giving me 50. So 50 units. 50 units will give a maximum profit of how much? So I would just need to plug in that 50 into that function. So that would be negative 4x squared plus 400x minus 3600. Oops, I forgot to... What in the world am I doing? I forgot to plug it in, didn't I? A lot of people forget that. And I did too. And we get $6,400. Now I could plug that 50 back in to find out what my cost is for those and what my revenue is for those. Because all of that will be based off that same number of units. Now, in this next example, we have the demand function for a commodity is given by this equation, and the supply function is given by this one, and we want to find the market equilibrium. So we want to let's start by let's start with the supply function. Okay, so let's say I took that supply function. Let's start with supply, and it's 2p minus q minus 38 equals 0. And if you remember from Unit 1, we wanted them to be solve for p. So we want to solve for p, get p by itself. So we get 2p equals q plus 38. So p equals half of q plus, what is that, 19? And the reason I'm going to do that is because what I'm going to do is, since we've got these two equations and two variables, I'm going to kind of use a substitution. I'm going to take this function and plug it in for p in this one. So now I'm going to get 1/2 q plus 19, because we got two variables and two equations. We want to use our systems of equations. I'm going to distribute and get 1/2 q squared plus 2q plus 19q plus, I don't know what 19 times 4 is. That's 76. And then minus 400. Okay, so I could factor this. You could even use quadratic formula if you would like. I'm gonna go ahead and factor it, because it will factor. But I'm going to multiply both sides by a 2. So 2 times 1/2 would just give me a q squared plus 42q minus, what does that end up being, 648. And if I multiply 0 by 2, I get this. and then 648. Now, I know that it factors and so forth. Let me back up a second. What if you had trouble factoring from here because these were too big of numbers? Let me go ahead and show you something that you can do on any calculator. Let me go back up to this one. I'm going to put that equation in the calculator. So that would really be a 1/2. The calculator is going to call it x squared plus 21x minus, 324. And I'm going to hit the graph button. And I'm not seeing too much, so I'm zoomed way too far out. Let's bring this in, and it could also be negative. So I'm going to change my window. Well, I don't know if it's negative or not. I'm just going to bring this down to 50 and bring this down. This can even go to 100 because I'm trying to zoom in on what's going on here. But I only see part of this parabola. It should be a full parabola. So you can also try zoom fit. Now the beauty of doing this on Desmos is that you can actually drag the window around. I'm still not seeing everything. So I'm going to give myself the other side of this and see if I can see it better. Because we're looking for when this is 0, so I'm looking for my x-intercepts, the zeros of the function. And I can see where it's crossing the x-axis. So here's where I'm going to give you a little bit of calculator help. This does factor, by the way. So if you want to spend the time and factor it or use quadratic formula, it will work. But there is the feature of 0 on the calculator. This finds zeros. So I'm going to press 2. And then left bound means I need to take my little cursor and keep moving it, keep moving it, keep moving it until it's to the left of where that 0 is. And I'm going to press enter. Right bound, I'm going to go to the right of it and press enter. Whoops, I did not press enter. Oh no, I got to start over. Left. And yes, if you mess up like that, you do have to start over. Guess, and it gives me an answer of negative 54. And then the other one, well, it's going to be between 0 and 50, because that's how big the window was. Okay. And it gives me another answer of 12. I want you to think about this, though. Would it make sense to have our market equilibrium be when, oh, this would actually be Q, when Q is 12? No, that doesn't make sense at all. So and when it's negative, no, because this is our quantity. Q stands for quantity. A quantity of negative 54, that's not going to do anything. But a quantity of 12, I can go with that. So I'm going to plug that 12 back into this function. And I'm going to get a price of 25. So our market equilibrium is for 12 items. Oh, actually this was supposed to actually be in thousands. I'm sorry, 12,000 items. I just messed up and forgot to put that in the instructions. At $25 each. So you can use the calculator to solve by using that. You could have also rewrote these to both be P equals and then found where they intersected. That would have been another way to solve it with a calculator.